All right, so find the equation of the line that goes through the point 3, 1 and has a slope of 2. This is for calculus. It's going to be a recurring question. So here, find the equation of the line that goes through this point. So you need a point and a slope. So let's call this point 1. Point 1. Let's say point 1. This is a point, and so this is going to be x of point 1, y of point 1. You need 1 point and a slope. And this is called the formula of point slope formula. Let's go with point slope. Write this down, point slope form of the equation of a line. There's other ones that you probably did was y equals mx plus b. But in calculus, point slope form is the way to write the equation of a line. And here it is. This is one that it will come up a lot. Y minus y1 equals m, which is the slope, and then x minus x1. That is called point slope form of the equation of a line. So there's 3 things we gotta plug in numbers for here. So we're gonna go with y minus. We're gonna plug in something for m. X, leave it alone. All right. So what do we plug in for m? What should I plug in here for m? Anybody? Louder, say it. What is it? 2. M is slope. So we're going to plug in m is 2. Slope is m. M is 2. So m is 2 here. Plug in m is 2. There's point 1. So you're going to put, for x1, you're going to plug in what for x1? 3. And then for y1, we're going to plug in what? We're going to plug in y1 is 1. So there's this. This is it. That's all we need. We're done, really. That equation right here satisfies all the points of the equation that goes through that point 3, 1 and has a slope of 2. So look, we have so we have the equation here. No, we have it here, and let me give you the graph of it. And let me just kind of show you that it does satisfy all the points on the line. And I'm just going to choose another point quickly. And I'm telling you that this is an equation that satisfies it real quick. Okay? Let me choose a point here. Look. What are the coordinates of this point which is on the line? Anybody, what are the coordinates? 1, -3. 1, -3. And it better satisfy this equation. I just chose that. I could choose an infinite amount of them, any point on the line, and just so you'll know. So it makes sense. So these y and x's are variables now. So if they're variables, so this is x and this is y, and if I plug in y is -3 here, y is -3, and I subtract 1 equals 2. X is 1. 1 minus 3. It better be true. So -3 minus 1 is -4. And then I'm saying that is equal to 1 take away 3 is -2. So this is -2. So what is 2 times -2? Oh, -4. Yeah, I was going to write the wrong answer because 2 times -2 is -4. And -4 is -4. And it satisfies it. And I can choose any one of these points, any point on this, along this, forever down, forever up, that satisfies this equation. So this is point slope. But what you're used to, maybe if you remember this, I'm not even, yeah, that's enough. Let's move on. So this is called point slope. here was another question we had last time, and we did this where I gave you a quadratic equation. And so this is something -2, +4. You don't have to write this down. I'm just gonna remind you of what we did last time. Look, so you have a quadratic. A quadratic equation, it keeps changing. The rate of change of it keeps changing. So the only one I'm pretty certain of is the rate of change here at the bottom is 0. The slope here is 0. And what I do know is the slope here is some kind of negative. And it's a tangent line. You need to know it's a tangent line. So right here is some kind of positive. But what exactly is that rate of change there? That's the question. That's what calculus is. And that's what we're going to do right now. All right. So can change occur at an instant? Here we go. Write this down. What is the slope of the line tangent to the graph of f of x equal x squared at the point 1, 1? So now, for homework, I gave you a bunch of different graphs, and you have to find the different average rate of change for different ones. Today, right now, we're going to focus on one graph only. And we're going to try to find what is that rate of change exactly at the point 1, 1, 1 of the quadratic. So there's 1, 1 right there. So here's the question, and it was always asked for thousands of years about what is the slope here. What is this slope? What is that slope? And we're going to find out right now. We're going to approximate what it is. All we're going to do is going to do repeatedly what we did, was it yesterday or 2 days ago, about finding the average rate of change. But we're going to do it to the same graph. The average rate of change, what was that? F of b minus f of a over b minus a, which is kind of like just the slope formula, wasn't it? And I have called a average rate of change. The average rate of change is also the secant line, the slope of the secant line. So here's the idea again, before I even do everything. It had to always be some person thinking outside of the line, outside the box, and saying, well, how can we figure it out if it's not a straight line and it's a curve, that we can figure out what is exactly the rate of change of any curve. And so say, you don't have to be copying what you guys just listen. So some really just smart person just says, well, if I wanted to find the rate of change exactly here, I can go ahead and get another point on the graph. But then if I connect these ones here, like we were connect these ones, this is called a secant line. That's a really bad approximation right here. If I connect this point with this point, that's not what's happening. But if I get this one to get closer, closer and closer and closer to my point here, then I will get a good approximation, even better and better. Watch, that's really bad approximation here. So if I do this, watch, if I leave this there and make this point get closer and closer and closer, and say I stop here and I connect the dots again here, and then make a secant line. Oh, this is a good approximation, but the actual thing should be like this. The actual tangent line should be like this. But that's a good approximation. But if I make it get closer, here, I'll go back. I make it get closer and closer and infinitely closer, then the tangent line, the secant line will become the tangent line. That's the idea of this calculus. So if I keep this like fixed and I get points coming from here, and I need 2 points to draw a line, and I make them get closer and closer to this one, but not be the same one, then we can find the tangent line approximation. So here, let's do it. So what we're going to do is going to do that. We're going to choose intervals. What if I use definitely, this is A, and this is going to be B. We're just going to be doing repeatedly what we did the other day. And we're going to choose points. We're going to go from 1, and the next point will be 1.5. 1.5 will be here. And that's arbitrary. You're like, so how far from that 1, 1 are you going to get the other point? It's arbitrary. Nobody could tell you. I'm just choosing 1.5, but it doesn't have. It just has to be a little bit to the right, and then get that point, get closer to it. So I'm gonna then stop, and then I'm gonna get it closer, 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 but not be it. All right, and find the slope of it, which is gonna be called secant, the secant line. So my interval is going from 1 to 1.5. And it's, like I just said, this line is very close to it, but it's still not it. They're not the same, but it's close. So there it is. We're going to use that formula, the average rate of change formula. All right, let's do it. So let's find the secant, the slope of the secant line. This is A, and this is B. What do I plug in? What do I plug in for B here? Anybody, please? Let's just do it. What do I plug in for B? What do I? Are we gonna having the same problems we had last time? What do I plug in for B down here? 1.5. Minus, what do I plug in for A? What do I plug in for A? 1. Then we're going to do f of 1.5 here minus f of 1. Let's work out the bottom already. What's $1.50? Take away $1. 0.50 if you wanted to. Okay. What's f of 1.5? Loud. Isn't it? All right, look up here. And here's where I'm telling you that this is going to get, it gets more and more complicated if you don't understand pre-calculus. F of 1.5, you can go ahead and look at here, and you're going to say, well, here's 1.5, but then I go here, and I'm going to just say it's, I don't know what this is. I don't know what it is. I don't know what it is by looking at this. But if you understand that this is this, then you can go ahead and plug it in and plug in 1.5, f of 1.5. So plug in 1.5x here, and you plug it in here 1.5, and then you can do 1.5 squared and get it. Get your calculators. If you can't do that, put 1.5 squared. It is not 2.5. still people are just sitting around. What's 1.5 squared? I think it's 2.25. Yes or no? All right, so it's 2.25. This is 2.25. Minus f of 1. Use your calculator. What's 1 squared? Please don't say 2. 1, yes? All right, so we got what? 2.25 take away 1. What's 2.25 take away 1? I think it's, is that 1.25? And so go ahead and get your calculators and go 1.25 divided by 0.5. Is that? What's 1.25 divided by 0.5? Is it there? What is that? You said 2.5, is it 2.5? Okay, so that's the idea of this. And so, let me erase this. So I already have it. So we're plugging A and B. You went home, you did the homework. You know how to use function notation. And you plug it in, and it turns out to be 2.5. So what this is saying is that this right here, the slope of this line, this line right here that I drew, that is called tangent line, the slope is rise up 1, 2.5 over 1. So but that is not the actual one. What I want is this. It's close, but the one I want is this. All right, so what we're going to do is we're going to get rid of that one and get it closer. Get it closer here maybe. And then do that. All right, let's do that. Make a table. Let's do another one. Get it closer. What do you think I'm going to use for B now? Getting much closer would be 1.1. I'm going to use 1.1. Again, the minute somebody says, how do you know you use 1.1? It's arbitrary. Definitely just get it closer to 1, but not, definitely not B1. Just getting it closer to 1. And 1.1 sounds good. So we're going to do it again. And hopefully the slope gets closer and closer to what the slope is. So, if you did the homework, and I'm saying in this class, I'm going to tell you, for those people that don't do homeworks, you either be really, really good at math and you understand, or you're going to fall behind, because you need to practice doing this if you're going to be So, B is what for this. I'm doing it again, but we're working it for this now. What are we plugging in for B? Underneath right here. Let's go. Somebody. 1.1 minus, this is repetitive, minus 1. Then on top is going to be f of 1.1 minus f of 1. Well, what's the answer for the bottom? What's the answer for the bottom of the fraction? 0.10? Yes? F of 1.1. I can't do that in my head. Well, I think I can. Let me see. Yes, I can. It's 1.21. So F of 1.1. So put it in the calculator. What's F of 1? What's 1.1 squared? 1.21. Yes? So it's 1.21. Minus F of 1. What's F of 1? 1. So now, what's 1.21 minus 1? 0.21. 0.21. And what's 0.21 divided by 0.10? It's 2.1. Yes? So now that they're closer to each other, we're getting, this is 1, this is 1.1. Now we're doing this. The slope of this is rise up 2.1 over 1. So we're getting close to the answer. We're getting closer and closer to the answer. So this is 2.1. We're going to get closer to it again. So we did 1.1. What should I use now? It's arbitrary. What do you think? Definitely don't say, okay, we're going to use definitely 1, no? The minute somebody says, should we use 3? Should we use 3? We want to get closer and closer and closer to this green line. Why would I want to go to 3? Just for people that are like would think 3. So what would be something closer that is close to this one? What would be something closer? Say 1.01. Is it 1.01 or is it 1. Oh yes, it's 1.01. $1 and a penny is very close to $1. Yes, yes. So they're close to each other. You getting the idea of this? The idea is that the 2 points are getting closer and closer and closer to each other. And we're going to do it again. Can we already get the answer? Didn't I already say the difference between them is a penny? So a penny is 0.01. So the difference between A and B is 0.01 at the bottom. F of 1.01 minus F of 1. Get your calculators. That one I cannot do it. I can't do this. You got to get a calculator. Get your calculator and give me the answer to 1.01 squared. What's 1.01 squared? What's 1.01 squared? Okay, I'm getting 1.0201 minus 1. So go ahead and do that. 1.0201 minus 1, divide that by 0.01. What are you getting? Anybody, let's go. What are you getting? 2.01? 2.01, yes, 2.01. So it's a pattern recognition here, everybody. What is it getting closer and closer the slope to be? It's getting closer. Let's confirm it. Let's go from 1 to what? 1.001. That they're so close to each other. I went 1.0001 just to make sure that it is going to be 2, that the slope is 2. Start messing up again. So the difference between them is 0.001 at the bottom. At the top is going to be f of 1.001 minus f of 1. So 1.001 squared I am getting this number, 1.002001 minus 1 over 0.001. What did you get? So learning this math, you gotta be doing it. You can't just, so what did you get? Anybody? 2.001, is it? 2.001. So we can go ahead and deduce, and we can just say that the slope is 2. We can just say that the slope here is 2. So now I know the equation of the line and I know the rate of change at this point. The rate of change of this point, I'm pretty sure is 2. So if I know this m equal to 2, and I know the point here is 1, 1, then I can write the equation of the line that is tangent to the curve at this point. So how do I do that? Y minus y1 equals m, x minus x1. So it's going to be equal to, plug in m. What do I plug in for m? What do I plug in for x? Louder. What do I plug in for y? Is this? Yes? That's the whole lesson for today. We are done.